Hello, Neural Network listeners. Our names are Vasu Lakshmanan and Arman Priyadarshan, and we are your podcast co-hosts. Today, we're joined by Dr. Corso, a renowned professor in robotics and EECS, electrical engineering and computer science, and the co-founder of Voxel 51.
Dr. Corso, you'd like to introduce yourself for the podcast?
Sure. Thanks, guys. It's a pleasure to be here. Yeah, I'm Jason. I've been on faculty about 20 years now, and Voxel 51 has been around for about 6 or 7. So it's, lots of experience as an operator of a startup, as also a researcher. So happy to talk to you guys today.
Yeah, thank you very much. So for a starter question, how did you come up with the idea of Voxel 51?
Yeah, I mean, I think the key rationale behind starting a company as a faculty member, especially one in which I was going to be an operator, right? Like actually to actually build something and be involved in on a regular basis,
Mhm.
was based on a couple things, right? One was as an academic, we do a lot of research, we get grants, we do research, we teach, and so on. But oftentimes the impact is really long term and drawn out, right? Like you write a paper one year and you might not see the impact of that paper for a decade or more. And I wanted to see what bigger impact I could have to sort of bring to the world. In fact, it's like measurable immediately. I think I have something like 20,000 citations of my academic papers,
Wow.
and Voxel 51's main software package, which is like a data creation tool for like when you're building models in visual AI. We have more than 2 million open source installs, right? Like 2 million, 20,000, quite different. But anyway, it's also it's great. But the second reason though, as well as I guess like my co-founder Brian and I, like we kind of saw the like clearly AI was like gaining some traction as we
Mhm.
built bigger, more capabilities and bigger systems and so on. And but yet we observed that a lot of the best practices that we had learned over the years in research and so on, like studying your data, really being a scientist about the performance and so on, were really going by the wayside and being replaced by just looking at F1 scores or accuracy scores or whatever aggregate metrics. And that just isn't in our view, the best practices to build the best system. So, we wanted to build a company around essentially cultivating the best practices. And that's partially why it's open source as well, right? Like we do have a commercial offering on top of it, but like for a single user, working on a single problem, like, it's really available as well. So yeah, yeah, exactly.
Oh, sorry, I was muted. How did you meet your co-founder?
Brian actually took a computer vision course with me in 2014, actually. He was a student in the course, sat at the front of the room every time, like really, so it's the kind of student a professor really enjoys, and is also like, he kept me on the ball, right? Asked really good questions, clearly grokked it. And then we reconnected a few years after that course. He had built the auto grader software for the EECS department at Michigan. So I had to sort of learn how to use it, and that's how when we reconnected and started talking about future ideas.
Really cool. And what about computer vision kind of made you want to stick to it?
Well, it's a good question. I mean, I've been in computer vision for a long time. I mean, I dabbled in computer vision when I was a sophomore as an undergrad. I had like an undergrad summer research fellowship type thing, and really enjoyed this project. It was about like how can you do texture analysis of glaucoma images to help for glaucoma diagnosis. Obviously, as an undergrad, second year, we didn't make that much progress, but just the practice of doing that was really fun. But for me, I mean, I like, frankly, I could be in any field. I really just enjoy problems and working on problems and kind of like anything. But I guess I tended to gravitate toward vision, HCI, and computer graphics because I'm also a pretty visual person. I like it, just enjoy the visual world. And it was just like a sort of a natural inclination to stick with it. Yeah.
Yeah, that's really cool. Could you elaborate a little bit more on how the auto grader works?
I wish I could. Let's see. I'll do my best. This has been some time since we did that. So it's pretty cool, right? Like I think the way they set it up, basically, if you have like a problem set for computer vision tasks, right? Like implement a HAR feature wavelet as part of AD Boost or whatever, right? Like when you're setting up the assignment, you set up like you have to configure each problem and the plausible space of outputs, whether or not they're deterministic or even like sort of like a set-based or probabilistic outputs. And then when the user submits, I guess the submission was configured to be an attachment to an email to a specific like course-based account in the department. It would then go and add that attachment to a queue with the right metadata for the student who sent the email. And then students like it though because like they get feedback rapidly, like in a day, less than a day, right? Like so you can kind of iterate on your assignments. And it's not that hard to configure. It's a really beautiful piece of software that Brian implemented actually. Yeah.
Makes sense. It's really cool. In one of our previous episodes, we had like Dr. Neil Heffernan, who made an assessments tool for WPI, which is also kind of similar in terms of auto grading and ed tech.
Nice, yeah. I mean, ed tech's an interesting space, right? I there was this tool I used to use in teaching called Nota Bene. It was like this interactive kind of like spatially grounded commenting, right? Piazza is a common tool that people use in teaching, but like in Nota Bene, you upload a PDF and then people read the PDF together in a class and they like make comments over highlights and so on. So it's like shared group reading. And recently I switched from Nota Bene to this tool called Perusal, which is the same thing not only for PDFs, but also for videos. So like I flip my classrooms now and I upload pre-recorded lectures and students can kind of like, highlight a temporal segment of the lecture and ask questions about it and other students can answer it. It's all part of this growing field of ed tech. I mean, I guess I'm surprised there aren't many, maybe there are that I don't know of, but there aren't many like these auto grader type tools, but maybe it's just like the level of flexibility is hard to get, right? Like like in what a faculty member might need. I mean, in fact, actually mapping it back to like my own startup, like one of the unique things that we do in our software tool 51 is right, like we don't try to get you to work in any specific way, right? If I've learned anything over the years is that like if you put 10 machine learning engineers or machine learning scientists into a room, there's like 100 different ways they want to work. Right? So like 51 is all about flexibility. And it was hard to achieve the level of flexibility needed. Maybe that's why in the ed tech space there isn't much. There aren't many auto grader solutions, although maybe there may be, and I'm missing them. But yeah.
Yeah, I think one of our friends was working on something that uses OCR for like grading math problems. We thought that was pretty cool. And
Yeah.
also more on Voxel 51's service, like 51, like how exactly does that work?
How exactly does Voxel 51 software work?
Yeah, like what kind of services does it provide?
Yeah, so I would think of 51 as like a experimental toolbox that is specifically designed to support the work of a machine learning research scientist or computer vision engineer. I guess you guys are probably too young to know what MATLAB is. Maybe but it's kind of like MATLAB for computer vision and machine learning, in the sense that, essentially it provides a data model that's implemented in Python on top of a NoSQL database that allows you to represent your data set, like the raw media. Like it's a logical data model, so it points to the raw media off wherever it's stored. Basically, open source, it has to be on local disk, but for enterprise, it's like in the cloud or on some NAS or something like that. But um, and you can have as many attributes as you want on those data samples. And those attributes are of different formats, like they can be scalar fields or bounding boxes for detections, or they can be like evaluation runs from your models, right? And then there's an app component of it that allows you to visualize both the samples and those different attributes, and it visualizes them and depending on what they are and how you want to use them. And actually coming out in like a week is the ability to implement what we're calling panels, which would be like these new novel views based on what's in the data set in your problem, right? Like if you want to evaluate two models and compare their performance together on one data set, and they're both like as these attributes on your data samples, you can use this new like model evaluation panel view that like allows you to visualize the performance and do the key things that are like, finding the failure modes of model A versus model B, or like finding cases where they both fail for that matter, right? Like those are really key components of the day-to-day work of machine learning scientists and engineers. Yeah.
Yeah, it definitely sounds really interesting. I was wondering what were some of the challenges you and your team might have experienced while developing Voxel 51?
It's been a journey, right? So my co-founder and I are not business people. so we don't have any training in the business world. I mean, I've always had one foot in like the practical world. I've consulted for forever for different companies. And so I like have that penchant for product, I guess you could say. So we had to learn a lot though from scratch, right? Like we were really lucky to have good investors from our seed round all the way through our Series B. Like, our investors are like, really solid blue chip people who understand the value of open source, understand the value of like the team and the patience and so on. So just like, but being able to like roll up your sleeves and have the grit to like persist and like keep doing the work uh, is not was a lot actually, or has been a lot, and it continues to be. From a technical sense, though, like um, I think like we initially built a company that wanted to essentially leverage our expertise with video understanding, right? That's my field at the university. It's my research and so on. Brian did a PhD on it, and for example. But we ultimately like the willingness to meander away from your initial ideas toward what the market was telling you, like to actually build a product that was useful, was really important. I think we're both sort of wildly willing to do it, right? But we had to throw away like the willingness to throw away past code is not something a lot of engineers take lightly, for example. But we did that happily. So I mean, those are some less technical elements of the difficulty. I mean, in a technical sense, like one of the key aspects of 51 is that these data sets in computer vision are large these days, right? Like massive data sets, billion samples, 100 million samples. Whether or not actually need that many samples to do the work that we're doing, that's how big they are. So we really couldn't build it in a SaaS mechanism, right? Like it just wouldn't have been a viable technical business model, if you will, to go and store all this data for everyone. Furthermore, no major Fortune 100 company is going to go trust some 20-person startup with their data either. So we actually had to go and figure out mechanisms to basically manage the control plane for our users while letting them maintain control of their data plane. And it allows the flexibility that I was telling you guys about earlier, but it wasn't necessarily a natural motion for us to do technically, especially because like, right, there's the media, but then there's also the database that we're maintaining to maintain all those attributes so that you can query in Python or natural language, query your data sets and ask the right questions about it. Like we need to have full control over that, that database is going to live on the customer's property, right? So it was an interesting challenge, but we've definitely overcome it. But it definitely was a good challenge.
Based on your experience, would you have any advice for other people trying to make an AI startup?
Yeah, I mean, I guess like at Voxel 51, we chose the picks and shovels route, right? Like we build a developer tool essentially that supports the community. And not that it's been easy or it is easy to do that, but I think building infrastructure is frankly a lot easier than building capability, right? Like going out and saying, I'm going to go build a whatever, like just some random product. I don't know, count the number of empty mugs that are left on on tables in coffee shops, right? Like that type of seemingly simple, wildly complex to get right with a good enough fidelity to go and deploy. So I think the key element, like if you're going to go build a capability, which is great, the world needs capabilities. You better make sure that it's a capability that's not just in your head, but it's actually in the market, right? Like you have to go talk to people first, make sure it's needed, make sure there's value, potential value in it, and don't engineer before you know that. Like a lot of engineers like to build first, ask a question later, right? That's a good way to fail. So um, I guess that's the one key learning, really.
Yeah, I think that's phenomenal advice for future entrepreneurs who are looking at AI as a route to accomplish that. I was wondering if the future of the company and what you guys are thinking of exploring inside the near future in terms of Voxel 51.
Yeah, right. So I mentioned the panel, so that's a really big deal for us. The ability to, I mean, you could always build plugins, not always, but for like a year or so now, you could build plugins that could change the functionality both on the front end app and the back end. But to do it at the front end, you need to learn React and know JavaScript and all this stuff. And like well, not many machine learning engineers also know React. It's just not like kind of two different spaces. With panels, you can you can add that functionality in Python directly. So you don't have to learn any front-end UI, like whatever your Python code is, as long as you follow the protocol for the panel infrastructure, it will get rendered and made usable in the app, even with interaction, right? Like if you build a confusion matrix panel, you can kind of click on one of the cells and that runs a query that you want it to, for example. That's part of the initiative we have for 2024, which is to like broaden the reach and make 51 as easy to use as possible, right? It's one struggle we have had is that 51 is pretty capable. It's like a full-fledged Python library, even in open source. I mean, even in enterprise adds even more complexity because we have a lot more functionality in it. So there's a high learning curve to get to learning it. It's not like certainly not a no code ML GUI or whatever, right? So, so we realize this is a pain point for adoption, despite the 2 million installs. Uh, Big deal about adding courses, adding new training material, and so on. So that's one big direction we're working on. Another big direction, which I'm personally excited about, is that we have recently launched a machine learning research team. And we're actually looking at some of the key questions around like how do you actually assess the quality of a data set? How do you actually assess like how to add what new sample should I add to this data set, like data selection, right? Like in order to improve a specific model, right? Like how can I understand the embedding space in a way that can explain to me what I should do next in order to improve my work? So I'm really excited about that actually as well.
It's awesome. Yeah, I know for sure. Like I have like a primarily a background in ML, and like I've been trying to do some React lately. It's not been going too great.
I mean, I don't know. I love programming myself, so I think there are many people who really do a lot like widespread different style programming, I guess. But there are some, right? It's possible, but it's like you can't build a tool that caters to the some. You have to build a tool that caters to everyone. So.
Yeah, for sure. And we're running a little towards the end of the episode, so for like a final question, regarding the University of Michigan, it's a great university that both Vasu and I are interested in as for seniors. So would you say there's any aspects of the school that attracted you to research and teach there?
Um, yeah, I mean, I was very attracted to the like the breadth of expertise, right? Like the ability to go. I mean, not only is the engineering a great school, but like to go to the school of medicine and find colleagues that are also top of their game, or go to the school of nursing. I have a collaboration with someone in nursing as well, like exceptional scholar, across to the arts and sciences. Like that breadth of expertise is really unique, really nice. That was one of the key aspects. I think another aspect was, um, I mean, the culture at the University of Michigan is really healthy. I have a great set of colleagues who just appreciate that, um, that every student, every one of their colleagues, that we're all human beings, right? We all have day-to-day challenges. We all have yearly challenges, right? Like sometimes we don't always bring our best foot forward, and no one's gonna challenge you in unnecessarily in certain moments for that, right? I think generally the culture is pretty healthy. Um, and then I think the third component was for me in particular, right? Like so I do computer vision, but I am really interested in a type of computer vision that is sort of like physically grounded computer vision, right? Like I haven't written many papers about like let's just go on the internet and produce a huge amount of data and then only train models on that data and we're done, right? Like a lot of the perception in research work that I do is work that could be deployed on a robot or could be deployed in augmented reality, right? It's sort of like physically grounded to help processes that are in the actual world. And when I joined Michigan, there was a large talk of a building out like a robotics institute and like putting a lot of research funds from the university behind robotics and that sort of physically grounded world. And lo and behold, a decade later, we're 2 years into one of the very few robotics departments in the U.S. with a robotics undergrad program. And I'm talking right now from the robotics building, right, Ford Robotics building. So, they kind of they have the resources to put investments in directions they believe in, or we believe in at Michigan, and I think that's pretty healthy.
Yeah, I certainly think it's really cool how innovative the location is alongside that the nice culture that you mentioned to really benefit everyone there and maintain that positivity moving forward to collaborate and continue to develop research interests. I'd like to thank you for your time today, Dr. Corso, and thank you for listening, Neural Network listeners. That's Vasu, Armand, and Dr. Corso out.